Hello everyone and welcome back for the second part of our series about how to make a keyboard. So today we dive in the reel and we go into the layout. So in this video we are going to take the schematic we made before and transform it into an actual layout, placing every component on the board, making the outline and preparing the board for the production. So exactly like in the first video, we will need to link our KiCad library with our project. Okay, now that this is done, we will need to adjust the name of our switch because as you can see, the reset switch and the keyboard switch have the same command delimiter, and this can cause issue during the auto placement of our keyboard. So I'm just going to rename the reset switch as SWT1 for switch technical. Now we can readjust the numbering of the switch inside our matrix. Now we can assign every part in our schematic into a real part in the real world. So for this, we need to use the assign footprint tool. It's quite easy. Everything will be stored inside our keyboard CS library. So just activate the library filter. Each time you will try to link the schematic with a footprint, it will only show up the things that is present inside the library. We can assign the microcontroller, the reset switch. When you deal with the keyboard switch, you will see a lot of variants like 1U, 1.5U. This U means units and it's the size of the keycap you will be using. So actually it's quite easy for us because the Hillside keyboard only use 1U key. So we can just select 1U for every key in our matrix. Okay, now you can select the three remaining components that are the battery footprint, the connector of the battery, and also the mounting hole. It's nice to select these standard things inside my library. It will be really useful when you are going to design the case of our keyboard. Okay, now you can go back into the PCB editor and just click Update PCB from Schematic button. This will import every of your linked schematic inside the PCB editor. Okay, now we need to find a way to specially arrange every key inside our PCB. For this, we are going to use the KiCad plugin, but also we are going to use keyboard layout editor website. So in my case, since I'm building again the Hillside, I'm just going to go to the repository to grab the layout file. Even if my layout is already prepared, I'm going to need to erase the right part of my keyboard. So I'm just going to go to keyboard layout editor to edit this layout. As you can see, it's super straightforward to import. And when I import the layout, I can just cut down the right part. Now that I'm happy with the layout, I can just export this file as JSON and we will import it thanks to the KiCad plugin. As you can see, every key is arranged correctly, but the numbering is not valid. The numbering doesn't follow the organic way inside the schematic editor. For this, it's a bit bothering, but we will need to rename every entry to the corresponding one. The easiest way to fix this is to put the PCB editor on the left of our screen and the schematic editor on the right on the screen. Right now, you can jump between left and right in order to number again the schematic part. Now that everything have the right number, we can place our different components inside the PCB as well. For the moment, just do it roughly because you will need to adjust over time. There is an optional step. If you want to have the 3D render of your switch, you need to import the 3D model inside the install file of KiCad. It's really straightforward. Just drop the 3D model of the switch inside the folder containing every 3D model of KiCad. Now we need to draw the physical outline of our board. For this, it's super straightforward. Just activate and only render the user drawing layer. And now you can use the wire tool of KiCad to draw the outline following your keycap size. Make sure you make enough space for your battery's placeholder and also your microcontroller. And also, if you find that KiCad snapping grid is too strong, you can just deactivate it in order to have the wire that snap perfectly. Now that you have drawn your outline inside the user drawing layer, you need to change the layout into the Edge.Cut layout. So for this, just select everything and modify the layer. It's just a matter of back and forth in order to have everything that fits inside your outline. After you drew everything, if you notice that KiCad is not rendering correctly your outline, it probably means that some lines are not perfectly connected. For this, the best tool is the Hill shape of KiCad. Just select everything and apply Hill shape with a tiny tolerance. Personally, I like to add a little fillet on every of my border, and for this, just select everything and use the add fillet tool. Okay, actually you're nearly finished. The last step will be to wire every of your footprint in accordance with your schematic wire. But before this, it's nice to define our tracked width using a user rule. We need to go in board setup and use the net class editor. So just create a new class for our track, and the best, in my opinion, is to use 20 mils width. It lets you plenty of space, and in the same times, you have a lot of copper, so even if you are a bit rough with your keyboard, it will always work. Now you are ready for routing. Concerning the routing, I'm just going to show you the routing of the real Hillside remake, not the tutorial one. During this part, if you need more information, I have put in the description the a slowed down version, so you will be able to see all the routing process. Don't worry, it's really easy, just it takes time. Thank you a lot for having watched the second part of my tutorial series about how to make a keyboard. Don't forget to leave a like and to subscribe to the channel if you want more content about keyboard. The third part will be about how to make the case in CAD software.